On May 30th, a farmer in France had been passing down a road and found a young man who had been shot in the stomach. He was still alive. So the farmer got the authorities involved, and they took him to a hospital. Sadly, on May 31st, at 10 in the morning, he died at the Hospital Cochin at the age of 20. His death is such a sad story of a brilliant, passionate young mathematician. Throughout his young life, he had a series of ups and downs, including 3 rejections from the university where he applied to attend, 3 convictions that landed him in prison, and the death of his father. Through these difficulties, he developed a drinking problem, which didn't bode well with his temper. Shortly after his 3rd stint in prison, he moved into a hostel. While he was there, he fell in love with a woman who was close to his age. However, she had a fiancé. Regardless, he was in love with her and realized this love was dangerous. And so, he wrote a friend the night before he left the hostel, explaining that he was afraid that someone might kill him because of his relations with her. And he was not wrong. In the early morning of May 30th, someone shot him in the stomach. It was a sad outcome for such a brilliant young man with so much to contribute to mathematics. Additionally, the murderers remain unknown. His untimely death is a tragic loss to the world of mathematics and a stark reminder of the fragility of life. The history of math is our intellectual foundation for understanding science. Science, beautiful, remarkable, awe-inspiring science. It's the creative foundation for our ineffable future. Hi, I'm Gabrielle Burchak, and this is my podcast, Math, Science, History. In the year 415, the infamous philosopher and mathematician Hypatia of Alexandria, Egypt, was savagely murdered by church monks. This murder shocked the Roman community and its government leaders. Hypatia was known far and wide as a respected philosopher, mathematician, government advisor, and a professor. Hypatia, The Sum of Her Life, is a book that I wrote that looks not just at the circumstances surrounding her death, but also at the sum of her entire life. I weave in the details of her education, disciples, Neoplatonic philosophies, female contemporaries, and the many mathematics that she wrote and taught about. There is truly more to Hypatia's life than her death. Hypatia, The Sum of Her Life, written by me, Gabrielle Burchak, is now on sale on Amazon. Buy your copy today. Evariste Galois was born in 1811 in Bourg-la-Reine, France, to Nicolas Gabriel Galois and Adelaide Marie de Monte. His father was a Republican, head of the Bourg-la-Reine Liberal Party, and village mayor. His mother educated him at home until he was 12 years old. She was highly educated in Latin and classical literature and specifically taught him those subjects. Mathematics was not considered necessary at this time in education, so he was not pressed to study it. At 12, he entered the Lycée Louis le Grand, which today would be the equivalent of a high school. While at the lycée, at the age of 14, he developed a fascination with mathematics and politics. By the time he was 15, he had read the original papers of Joseph Louis Lagrange, including reflections on the algebraic solutions of equations and lessons on the calculus of functions. Reflections inspired his later work on equation theory, and lessons on the calculus of functions were a work reserved primarily for professional mathematicians. Galois was ready to attend the university by the time he was 17. He had his heart set on École Polytechnique, which is School Polytechnique, which is considered one of the most prestigious universities for mathematicians. In 1828, he attempted the entrance examination. Still, he failed because he was still not prepared enough with the capacity to explain his work during the oral examinations. As a result, instead of attending the Polytechnique, he entered the École Normale, considered a substandard institution. He applied at the École Polytechnique again in 1829 and was rejected yet again. Within the same year, on July 2nd, his father committed suicide after his political opponents had framed him. These events devastated Evariste and filled him with a sense of injustice, as he had been a first-hand victim of devastating political baseness. At 18, he published his first paper on continued fractions. Additionally, he was developing theories on polynomial equations and submitted 2 papers to the Academy of Sciences for the Academy's Grand Prize in Mathematics. Augustin-Louis Cauchy reviewed his work. The Academy did not accept Galois' work for publication. There are 2 theories as to why his work was not accepted. Some historians considered that Cauchy had asked him to combine his 2 papers for submission, which Galois did not. Others believe that Cauchy rejected his work based on Galois' political views, which Cauchy opposed. This time frame was when King Charles X had succeeded King Louis XIII in 1824. 6 years later, the opposition Liberal Party had become the majority. Struggling with this political opposition, King Charles staged a coup d'etat, instigating the French Revolution of 1830. Galois was a staunch Republican and wanted to participate in the revolution. However, the director at École Normale locked in the students, preventing them from leaving the grounds. Galois, considerably angry at this outcome, wrote a letter to the Gazette École with which he signed his entire name. Even though the Gazette omitted his name from the publication, the school gave him a notice of expulsion that would take place on January 4th, 1831. Galois, instead, quit school and joined the Republican Artillery Unit of the National Guard on December 31st, 1830. While in the Guard, he divided his time between mathematics and politics. However, the Guard had to disband shortly after he joined, as they were worried they might destabilize the government. While involved in the revolution, he continued with his mathematics. He tried to start teaching a private class in advanced algebra. Still, his efforts were minimal as he was more involved with political activism. Regardless, on January 17, 1831, Galois submitted his work on the theory of equations to Simeon Denis Poisson. While Poisson reviewed his work, Galois continued his efforts in the revolution even though his guard had disbanded. During this time, 19 officers of his unit were arrested and charged with conspiracy to overthrow the government. However, the officers were acquitted by April. As such, the military unit held a banquet in their honor. At the banquet, Galois stood and proposed a toast to Louis Philippe with a dagger over his cup. His fellow guardsmen cheered. As a result, he was arrested the next day and put in detention at Sainte-Pélagie prison for a month. Luckily, his attorney's convincing argument influenced the jury to acquit him. However, a month later, on Bastille Day, Galois marched at the protest in his National Guard uniform, heavily armed with pistols, a loaded rifle, and a dagger. He was arrested and put in prison again. While in prison, he tried alcohol for the first time, which led to an attempted suicide. However, his inmates stopped him. Concurrently, while this was going on in Galois' life, Poisson, on July 4th, 1831, declared Galois' work incomprehensible and suggested that, quote, the author published the whole of his work to form a definitive opinion, unquote. However, with all that Galois was doing for the revolution, he was unaware of this. Galois' trial was set for October 23, 1831, when he was sentenced to 6 months in prison for illegally wearing a uniform. While in prison, he developed his mathematical theories and finally received Poisson's letter. Galois was livid. As a result, he decided to stop publishing his papers through the Academy and instead publish them privately through his friend Auguste Chevalier. Regardless, he followed through on Poisson's advice and developed his work until he was released from prison on April 29, 1832. Within the month of getting out, he stayed in a hostel where he might have met the love interest, Stephanie Felicie Poteren du Motel. She was the daughter of the physician at the hostel. At this point, things get extraordinarily chaotic for him. According to letters between Galois and his friends, she had confided in him about some troubles that she was in. His letters about this confidential information to his friends have confirmed this disclosure. The night before Galois died in a duel, he wrote to his cousin that he found himself, quote, in the presence of a supposed uncle and a supposed fiancé, each of whom provoked the duel, unquote. He continued, quote, I'm the victim of an infamous coquette and her two dupes, unquote. This letter, among others, was written the night before his murder. He had stayed up all night writing these letters, including his mathematical testament in a letter to Auguste Chevalier, outlining his mathematical theories. It was attached to 3 manuscripts, which likely included the work that he had been doing while in prison, and the annotated copy of the manuscript that he submitted to the Academy. After he died in the hospital, there were mild riots in the street. People were upset. You see, Galois was a noted Republican and considered a dangerous political opponent by many. So, some theorists and historians believe that a female agent provocateur might have set up Galois. Novelist Alexandre Dumas named Pescu de Urbanville as his opponent in the duel based on newspaper descriptions, but Dumas is the only one who named him as the opponent. However, this doesn't make sense because de Urbanville was one of the 19 officers who was acquitted and celebrated at the banquet Galois attended. Additionally, a description of his opponent alludes to Galois' cellmate, Ernest du Châtelet. But these are all speculations, and to this date, his killer has not been identified. And so, on June 2nd, 1832, Evariste Galois was buried in a common grave at Montparnasse Cemetery. In his hometown, Bougle-Lorraine, a cenotaph in Galois' honor sits next to the graves of his relatives. Galois' friend, Chevalier, accused the academics at École Polytechnique of having killed Galois, believing that had they not rejected his work, he would have become a mathematician instead of devoting his life to the Republican political activism for which he was killed. His work had not been published for over 10 years, possibly due to the timing of his death and the French Revolution. Galois' manuscripts were finally published in France's Journal of Pure and Applied Mathematics in the October-November 1846 issue. In this work, Galois' profound analyses led to what is now known as Galois theory. This work shows that there is no quintic formula, meaning that fifth and higher degree equations are not solvable by radicals. And although mathematicians like Niels Henrik Abel and Paolo Ruffini had published previous work on this theory, Galois had extensive, deep research to show this proof. I will go into some of the details of Galois' findings, starting with the Galois theory. Galois theory profoundly connects field theory and group theory, focusing on the solvability of polynomial equations. Galois demonstrated that a polynomial is solvable by radicals if and only if its Galois group is a solvable group, generalizing earlier work that showed the general quintic equation cannot be solved by radicals. Speaking of groups, Galois introduced the concept of permutation groups to analyze the roots of polynomials. Galois showed that the symmetries of the roots of a polynomial, which is known as a Galois group, can show if the polynomial can be solved by radicals. Another incredibly brilliant theory that he contributed to was field theory. Many historians and mathematicians believe that Galois had the most pioneering models on field theory. In his work, he developed field extensions by adding the roots of polynomials and analyzing their properties. Galois also introduced resolvent polynomials. This was done to determine the Galois group of a given polynomial. So, not only did he introduce Galois groups, he also introduced a way to solve them by providing resolvent polynomials. Galois, through his work, established the foundations of abstract algebra. For some, abstract algebra is a challenging subject, and I know I struggled extensively studying abstract algebra, but still, As somebody who prefers pure mathematics over applied mathematics, I fell in love with this subject. Galois' work laid the foundation for group theory and the study of polynomial equations, which influenced the development of modern algebra. His ideas about the symmetry of roots of equations and the group structure associated with them became central to pure mathematics. Lest we never forget his passion for justice, his involvement in the political turmoil of his time as he fought for the ideals and justice for the people highlights a remarkable intersection of intellectual brilliance and civic commitment. Despite his life being cut tragically short, it's clear that his profound insights laid the groundwork for modern abstract algebra and revolutionized our understanding of polynomial equations. His pioneering work on Galois theory, field extensions, group theory, and more to this day inspire and influence physicists, chemists, computer scientists, and of course, mathematicians. Undoubtedly, his legacy is a testament to how brilliant ideas can transcend time, fundamentally shape the landscape of mathematics, and unlock new realms of possibility. Thank you for listening to Math Science History. And until next time, carpe diem. Thank you for joining me at Math Science History. Please remember to subscribe to the show. Also, if you could please leave a rating or a review, it would be really appreciated. Because those ratings and reviews really do help to increase my listenership, which help to get me more sponsors, which help me keep the podcast up and running. If you want to learn more about the history of math and science, please visit me at mathsciencehistory.com. If you like what you're listening to, and if you like what you're reading, please feel free to click on that coffee button and buy me a cup of coffee. Every cup of coffee that you buy helps me pay for the expenses that go into making this podcast. Also, if you're interested in leaving me a comment or chatting with me, you can always find me on your preferred social media platform, including X, Instagram, Facebook, LinkedIn, Goodreads, TikTok, Threads, etc., etc., etc. Just go to Google and search for Gabrielle Burchak. You can find me everywhere. Until next time, carpe diem.